All right, hello everyone. Hope you're enjoying the conference. I hope you saw a bunch of really cool stuff. I know there's a competing talk with one of the guys that was at the keynote right now, so I thank you for showing up here. So first off, I want to start off with a little hands survey. Who here has actually used Unity and done a WebGL export? All right, so a good amount of the people here, I would say it was about 60%. And then who here has actually taken that export and deployed it and put it up on the web? Okay, so we dropped down to about half of that original number. So first, let's talk about myself and why I'm qualified to speak up here. I was a game developer back in the dark ages, and that's why I left this slide completely dark. That's the dark ages before Unity. Worked on a couple games, Death Jr., Rock Band stuff. And then my most famous game of all is Care Bears Let's Have a Ball, just so that you know. It's a PC CD-ROM game, thank you. Built that in 2003. Now it's really a piece of shit, but don't tell anyone. And then for the second half of my career, I moved into web development. So the big company that I worked for that you might have heard of is Gliffy, and I helped them build their HTML5 diagram editor. So I took some of my games knowledge and ported it over to the web. And then Mobling was an HTML5 games company that was trying to compete with Zynga and didn't make it. And Tint is currently around right now, and they do social media marketing. I also teach courses on Udemy. And I'm the founder of Simmer.io right now. So Simmer.io is the YouTube for WebGL content. And debuting today, we're accepting WebGL uploads. And it's a simple drag and drop process, but I'll get to that a little bit later. And this isn't going to be one of those sales pitch talks, but there will be a minute or two of it. So let's talk about what I'm going to speak about here. We're going to talk about the history of Unity and the web. And what I found to be really interesting is that Unity has been a web-first platform since they shipped in 2005. So, now we think of it as deploying to a bunch of other platforms, but actually their Unity browser plugin was available when they launched in 2005 for Mac, and then the Windows version came out a few months later. We'll also talk about how to build and deploy WebGL. So the building part is for the people that have not built a WebGL item before. It's pretty simple. And then we'll talk about the different ways that you can deploy this thing to the web. So the easiest way right now is to use a shared FTP server. This is I hear of people using HostGator. I'm on one called Web Hosting Buzz for Rocco, Balsamo.com. And this is really a pretty simple and I guess almost naive way of setting things up, but it's better than nothing. Then we're going to talk about Amazon Web Services. So this is like the absolute major thing that any web developer uses. There's a bunch of other cloud services like Microsoft Azure and Google Cloud, but Amazon is the big boy, big girl of the group. And then, of course, Simmer.io, and I'll show you how to do the drag and drop deploy to there. We'll talk about how to take the Unity WebGL template and make it better. We'll talk about the Unity compiler toolchain, and this is how this actually works under the covers. So as far as most people are concerned, it's just you click the button and it works, but there's a bunch of other technologies here that are working in unison to make this thing happen. Mscripton, ASM.js, and/or WebAssembly. WebAssembly is really cool. I'll get to that pretty soon. And then we're going to talk about how to communicate between WebGL frame and JavaScript, both ways actually. We'll talk a little bit about how to access web APIs, and a little bit about Lambda and serverless functions. So that is how you create a backend for your site without actually having to deploy an entire Node.js or Apache server. So let's start off with the history of Unity and the web. So I grabbed this from 2005. You can see they have their beautiful on-brand logo right there on the front page. And what's really interesting is back in 2005, they did have the Mac OS browser plugin, and the Windows browser plugin was on the way. Skip ahead 5 years, and WebGL was announced. WebGL is managed by this group called the Cronus Group, and this is a screen cap from their 2010 site. It was really just a paragraph on a web page back then. Then in late 2010 and early 2011, we start getting browser support for WebGL. By 2013, all the major browsers support WebGL. And 2014, we get iOS WebGL. 2015, Unity 5.0 ships with a WebGL preview. And very soon thereafter, Chrome kills NPAPI. NPAPI, I have it in the notes here, stands for Netscape Plugin Application Programming Interface. So this is what enabled Unity Web Player to run. So they released this in 2015. 1 month later, you get this. We can't load your Unity Web Player game. Please download Internet Explorer 11. I don't think so. Okay, so December 2015, Unity removes the preview label. 2017, Chrome kills Flash. It's still around, but you actually now have to enable it or whatever, click some button to get it to work. So this is on its way out, and WebGL really is the way to put graphical content on the web now. In 2017, March, this is only a few months ago, Firefox and Chrome shipped with WebAssembly within 2 weeks of each other. I think Firefox actually won out. Then in 2018, we'll start to see WebVR and beyond. And WebVR is something that you can actually turn on right now in the browser with a flag. And I believe on some Windows builds, it is actually built in now. All right, so let's talk about why I should care about WebGL. The first thing is it's a web standard, and it's not going to go away anytime soon, right? The three big browsers have a consensus on how WebGL is supposed to work, and it's not going to be controlled by a single company like Flash or Adobe or even Unity for that matter. So really, it's open and available to anyone that wants to develop in it. Combined with WebAssembly, this is a technology that allows you to compile C++ and eventually other languages to the web. I really think this is the future of what we're going to see on the web. And I dare to even say Web 3.0. Sorry. No app stores, instant deploy. So if you have like an asset on the Unity Asset Store and you want to share it so that people can market it, right? You can just throw this up on the web, a WebGL export, and you can show off your model or game or whatever you're selling on the asset store. You can also throw up a demo of the first level of your game, something of that nature. And that gets me to zero friction, right? So they go to the website, the thing loads up. You don't go to Steam and download a demo. You just go and it shows up in the browser. We're going to start to see approaching of native speeds. Now, WebAssembly is basically a subset of common processor capabilities. So like for different platforms, you compile to WebAssembly, and this is bytecode that actually gets run in the browser that will be close to native speeds. You're going to be able to have new experiences where you're able to integrate with web APIs. Now, Unity standalone can do some of this, but like, for instance, if you needed a Google login button because you were connecting to Google Drive, for instance, right? You probably could do that within Unity, but it might be better to do that outside of the Unity frame. Connect to Google Drive and pull in images, for instance, from a user's folder. So let's do the basics of how to build WebGL, and I apologize to those of you who know how to do this. This is actually a recording that I made for a web development conference because I wanted to show them how easy it was to build this stuff in Unity. Now, there's a lot of ways to build WebGL apps that are not Unity, but I did want to evangelize this to folks in the web world, right? Since that's kind of the world that I live in now. So I show actually downloading Flappy Bird from the asset store and the whole process of actually exporting that to WebGL. So we search for it, we download the asset. Looks like I have it downloaded already. I import it into the project. Right, this is all standard stuff. And then open up the scene, play the awesome game. It works. I promise it's only another minute. Then I go into the player settings, and this is where you can fiddle with the WebGL settings here. It's that little HTML5 logo. This is where you can set the template and the resolution. A bunch of debugging settings down here. Then here's the publishing settings, and this is where that WebAssembly stuff is. That's also where you can set the memory size. I don't go over the memory stuff in this talk, but it is a good web search to do. You start doing these WebGL things. That's a common problem that people have is not fitting into memory, and you have to fiddle with that number a little bit. Anyway, so I'm finishing off this demo here where you create the build, and we look at a progress bar for 5 or 6 minutes, so I'll just take a break. I think I fast-forwarded it a little bit. This is the IL2CPP compiler, so it goes from C# to C++ to ASM.js, and eventually to WebAssembly instead. And you have this, your final beautiful Flappy Bird, ready for deploy onto the web. Okay, so let's get to how you actually do that. So the old school way is you use a shared hosting provider. For instance, like I said, I'm on this host. I don't necessarily recommend them or not recommend them. It's just called Web Hosting Buzz. HostGator is another one that I've seen thrown around. And you drag your stuff into a public HTML folder via FTP. Now, that's a start, but it has some drawbacks, especially if you're worried that your game might get popular. That's a good worry to have, right? So it doesn't have HTTPS. Doesn't have HTTP2. No CDN, and I'll get into what a CDN is for those of you that are not in the web programming world. You can't configure the caching level. The server can get overloaded. It's usually a little tiny piece of a server somewhere in the USA or another country, and the server's overloaded and your game doesn't get shown quick enough. People might hit the back button. So let's see about how we can do this a little bit better and deploy to a cloud provider. And again, the one that I chose for this talk is Amazon Web Services because it is the big elephant in the room. Now let's talk about, before we go into that, let's talk about what a CDN is. CDN is a content delivery network, okay? And so this is a normal setup right here. Let's see if my little pointer works. It doesn't matter. This is a normal setup here where you have a server, say in Austin, Texas, right? And people all around the country go around and pick this stuff up. Or, all around the world actually have to go out to Austin to get this stuff. Now, with a CDN, it's much different, right? There's all these little servers all around. This is a little bit simplified, right? It's got to do one request out to the origin, but then everyone in Liechtenstein can get your game quickly from a Liechtenstein server. So why care about HTTPS? You might say, well, I put a crappy game of Flappy Bird up why should I even care whether web security is on? And the reason for that is that Google is now actually lowering search results of websites that don't support HTTPS. So this is a major push to get people on the new standard. HTTP2, it's faster. And the other thing about HTTP2 is it only works in conjunction with HTTPS. And anyway, let's do a demo of how to get this thing deployed to Amazon Web Services. If any of you guys have ever used Amazon Web Services, you know 3 minutes and 56 seconds is not very long to learn something in there. So let's watch this little demo. So here's my Flappy Bird. And this is where you would sign up for Amazon Web Services. They give you a free service for the first year. Go down here to host a static website. And this is something fairly new that they've simplified this process quite a bit. Click New Website. And I take my WebGL build, compress it down to a zip, drag and drop it right here into Amazon Web Services. Forgot to put in a name. Okay, so now I can see this on the web, but it doesn't have all that fancy CDN stuff. This is straight from one web server. It's called S3. It's got that big, crazy, long URL at the top. We're going to fix that a little bit later, too. So this is running from a single web server, probably in Virginia, I think. And this is the content delivery network, and it takes 15 minutes for it to propagate all around the world, right? So I'm waiting for that. I'm going to buy a domain, and this is all built in now. It's 12 bucks. Right, now you can see it's registering, and I believe there's like a little back and forth web stuff or email stuff you have to do with them to get that thing fully registered. Okay, now this is what things look like. I mean, you're not going to see that big of a difference, but this is the CloudFront CDN. So this is what I was talking about, where it's distributed worldwide. And this also has a pretty strange URL, right? And we're waiting for that domain to set up, and it does take 24 hours because there's DNS servers all around the world that need to get the domain name. So in 24 hours, here we are. We have its Flappy time on the web, right? But this is not secure yet. And it also doesn't have HTTP2. And you can see that down here in the web inspector as it's downloading different files. So I'm going to go into the settings for CloudFront, which is the CDN. I promise this isn't much longer either. Then we go down here and we select a custom SSL certificate. And then we go into the Amazon Certificate Manager here. Grab the SSL certificate. Right, and then there's another email back and forth. I was really thinking about whether to click that button. I don't know. So, but back in the CloudFront settings, I go and connect this certificate. And I will eventually show you some articles that I wrote that actually go through this process. You also want to turn on HTTP2. I forgot to do it in the video. There's a lot of little things, right? And then you go into behaviors here. You edit the behavior. You redirect HTTP2 to HTTPS. You can set some caching settings up there, and you say yes, edit. Now, if I refresh, you see I have HTTPS going. And down the bottom, some of the things are H2 and some are H1. Looked like I had to do another refresh there, and everything's on HTTP2. So I got all that? So if you find me on Medium, I wrote some articles about how to do this, if you want to go ahead and do this. So just follow me at the Rocco B. Okay, let's switch gears now and talk about some more closer related things to Unity. Let's talk about how to build a better WebGL template. So if you look at stuff on the web, I believe this is from Itch, you see at the bottom there we have this Unity WebGL and ship control, and every single thing has this stuff, and it's got sort of this weird loading indicator. Everything looks sort of uniform in a way that maybe doesn't fit in with the style of your game. Wait for it. Okay, so here's what we're going to build. We're going to build something that's simple, responsive, unbranded. We're going to fix some of the weird messaging that Unity does if there's an error in the page. And we're also going to remove the mobile warning, which maybe you want to leave in still. I'm not sure. So here's the basics of how you get that going. Okay, so I'm in the terminal right now, and here is the WebGL template. This is the assets folder of my Unity game, and I'm sorry for using WebGL template in the name of that game. Anyway, I'm going to make a directory under the assets folder called WebGL templates. And then I'm going to copy a file from the Unity application to assets/WebGL templates. I'm sorry, it's actually a full directory. And that lives in Unity playback settings, WebGL support build tools, WebGL templates default. And then you copy that over into your folder after you dig through all those directories to find out where the default WebGL template is. Okay, now you're in your player setting, or now you go into your player settings, and now you can see that there's a new WebGL template available to you. And in order to just check that this is working, I actually went into the directory with the WebGL templates, and I added just some ugly header. I build it, and there it is with my beautiful ugly header. Okay, so let's understand the contents of what's in the index.html file that's in the Unity WebGL template. So on the left side, this is stock. This is what you get when you, actually it's stock plus my hello world. I guess I took the wrong screenshot, but it's pretty close, right? And then on the right side, what I did is I distilled this down into just a single global JavaScript variable, window.unity constants, and I move all of those items that are delimited by percent signs into this JSON construct. This is mostly for demonstration purposes, but I do end up using that construct in some of the later examples. So when you build this, you actually get a blank screen because now we're not instantiating the game. As you can see on the left side, it says game instance, Unity loader instantiate, and there's nothing like that on the right side. But for demonstration purposes, I just wanted to show that this fills in some values that you can use later in your WebGL template. Okay, so let's build this better WebGL template. So I'm going to go ahead and put the game container back. I got it down to something that was really, really small, right? And I'm going to add jQuery and a file called myloader that's going to live in that WebGL templates directory under scripts. And this is kind of going to allow us to get more control over our WebGL template itself. And I'm going to remove that footer, the one that had the Picard facepalm at the bottom, and is kind of uniform across all these WebGL builds. And then in my JavaScript file, this is the JavaScript file that's under scripts myloader.js. This is just a jQuery wrapper, and then we're going to instantiate the game instance. Now we have something minimal as a starting place, and let's take a look at what this looks like. There's no Unity stuff at the bottom, but also it's not responsive, right? So in the web, people sort of expect these things to be responsive these days, and this certainly is not. So we do this with a function. This is a JavaScript function. You guys are all really smart game programmers, so this is a simple fit one rectangle inside of another rectangle algorithm here. Here, I see a couple of you with their cameras out. You can take a picture. And what we want to do is we want to figure out what the max scale is that can fit inside the window, fix up some rounding stuff, and then we set the Unity width and height here. We need to set it both on the game container, which is the container that holds the Unity canvas, and the actual canvas itself, which is sort of a gotcha. Then when the person resizes the window, you have a window.onResize function, right, that calls set dimensions. So the problem with this is that when someone's resizing, it happens every single frame. We actually want to debounce this so that we don't kill the processor while people are resizing the window. So for a better performance, we just add this sort of debounce logic down here. Let's take a look at it. Wait for it to load up. So now we have this nice responsive window. Let's do a few other tweaks to the JavaScript code. So like I said, if you've done any WebGL exports, you might have run into this. Anytime there's an error in JavaScript or in the Unity browser, it throws up like this big in-your-face dialog. So the way you get around that is just to set the error handler, and you do this before you instantiate your game instance, right? So you set this to nothing. And then you get this doesn't actually override the console stuff, so you get your errors on the console, which is sort of a more sane thing, especially if you're deploying to folks around the world. And then this one's pretty small. I'm simulating iPhone right here, but as you can see, it says, please note WebGL is not currently supported on mobiles. That is mostly true. Flappy Bird does run at 10 frames a second. This is something that I really hope that Unity puts some resources into. But it does actually run. So I do some crazy hacks here to get this to work. This is like some pretty evil code. I override the compatibility check, and then up here, let's see. Up here, I'm like, oh, no, I'm not mobile. And then I go to the original compatibility check, and then, this is horrible code, but got to throw up at least one slide of bad code, right? For those of you with your cameras out, this is the full thing. I'll leave it up for 1 second. I'm going to try and actually release this on the Unity Asset Store because I think it's something that will benefit a lot of people, and I'll do that for free. Now we zip it up and upload this to AWS. And now we have its flappytime.com with our responsive stuff. So we've built something now that's simple, responsive. It has a cloud server. It's virtually infinitely scalable because Amazon Web Services is huge and they have that CDN sitting in front of everything. You're not going to run into problems with people overloading your game. You have all this all this fast new stuff, CDN, et cetera. But it was a lot of work, right? And so what I'm trying to do with Simmer is make uploads as easy as YouTube, right? Let's take a look at Simmer right now. And this actually debuted a couple days ago. It's a place for Unity developers to distribute WebGL games and eventually all WebGL games, but I'm focused on you guys for now. So I do a simple single sign-on with Google, log into my account. If you guys took a snapshot of that, you can get my private email. Oh my God. Okay, so I fill out my public profile, and I go into the upload page, and I drag that folder. This was the default Unity template. This isn't the one that I actually hacked together, right? It uploads. You didn't have to zip it or anything like that. It uploads, and then here it is on Simmer. Playing Flappy Bird. I promise there's a couple other demos besides Flappy Bird. It loads fast. That's basically the deal. Right, and so now your upload's live, but it's at a private space, and you can make it public. You can give it a URL, and it's sort of like a Twitter-like URL, the Rocco B/Flappy Bird style. I actually even collected a screenshot on that last page that I am connecting to things, and eventually I'll even make something where you can take your own screenshots of your game so that it's super easy to get these things up. Give it some categories, you save it, and then here it is live on the web at that URL, so at the Rocco B/Flappy Bird style. More Flappy Bird. Then I have it set up somewhat like YouTube, where there's comments at the bottom. You know, a lot of this is in limbo. I'm not sure what the final is going to look like, but this is what the beta looks like. And then the cool thing is that you can actually copy an embed code to the clipboard. And so say you have your site, mysupercoolgames.com, right? Now, just like YouTube, you can embed a WebGL. Right, and here's my super cool website with WebGL running. And Simmer handles all of the hosting costs and all of that crazy HTTPS stuff, all this responsiveness. If you change the size of that window that it's contained in, like I'm showing here, it'll just work. It'll just resize the thing. So a lot of cool little bells and whistles. I really wanted to make this something that people will get really excited about. So hopefully you do. With Simmer, there's a simple deploy. It's fast, responsive, and secure, and you can edit or you can embed these things on your website. And it's a place for your content to be discovered. I'm going to leave sign up open this week. I'm probably going to switch over to an invite mechanism, mostly because I didn't have time to get the invite stuff done. I wanted to give you guys all the invite code, but hopefully you guys give that a shot. And let's switch gears again. Okay, we talked a little bit about WebAssembly, and I even spoke about how I thought this was the new era in web development. And right with Simmer, I sort of think that this is going to be the death of the App Store. It's mostly to get people to click on the article, but when you say the death of anything, people like to click it. I'm learning things about marketing and stuff. Anyway, I actually really do believe that we're going to start seeing on the web very native-like experiences, whether built with Unity or not. But Unity's on the forefront of this, and they're really the only way to build stuff in WebAssembly that a sane person would actually want to try and pull off at this point, right? So let's take a look at how Unity export works. And this is a standard Unity export right here. And if there are any of the Unity engineers in the audience, I think I'm right with this, but don't. So I think this last step where it says C++ compiler gets filled in with this tool called mscripten. And then it exports to, instead of a native binary right there, it exports, to ASM.js. So ASM.js is zipped up in these Unity web files. And if you look at this code, this is what it looks like. Also pretty beautiful, very debuggable. So well, I guess the next logical question is, well, this is crazy, right? Why can't this just be binary? Right, and it can, right? Here's the WebGL experimental export. And this is what that little warning says at the bottom. It says, WebGL is an experimental feature and not enabled by any currently shipping browsers by default. This functionality is provided for testing purposes only. Wrong. It is available on all major browsers, except for Edge, and it looks like Edge has it with a flag, and you can get it in the next version of Edge. So really, WebAssembly is here today. So I've tried it with Flappy Bird, and it just works. And then I tried it with an awesome 3D game, and it crashed. So that's what that star is about. I'm sure they're working hard on it because this is a really cool future of the web type thing. And I know Unity is a web-first company. So in here, mscripten now exports, instead of it to ASM.js, it exports to WebAssembly if you have that little tick mark set. So this guy, his name is Ross, and he's out of Montreal, and he made this game Funky Carts. And this is not a Unity game. I know, blasphemy. But what I thought was really cool is he actually went in and wrote all about how he converted that game to WebAssembly. So if you're really interested in this type of thing, you can read his article, and I found it to be incredibly interesting, even if I didn't implement it myself. And then there's also WebAssembly Fiddle, Wasm Fiddle. where you can write C++ code on the web, just like, I don't know if you've ever used JS Fiddle, but it's a place where you actually just type in the code, and then it exports the bytecode that you can include in your web pages. Really cool for learning. I had a friend of mine actually build a fractal generator in here, which was pretty awesome. And I also wrote an article about this because I thought it was a really cool tool. And anyway, let's get back to Unity. That was sort of an aside. So let's talk about how we communicate between Unity WebGL and JavaScript. Okay, so it goes in two directions, right? I can go from JavaScript to Unity, and I can go from Unity out to JavaScript. So the easier way is JavaScript to Unity, which I'll show now, right? So in this little demo with Flappy Bird, again, I have a do flap button, and now this lives in the HTML page and not inside of the Unity context. So I'm clicking the do flap button, and it's actually sending a message into the game that is actually making the bird flap. This is the funny part, right? Watch. So I'm going to show actually the do flap function in the console there. I just send this to a Unity object, and then I can bring it back to life. So let's get into the guts about how this works, right? So this is the API. You can send a message to a Unity object. And this is a very good page for actually both directions. It's called Interacting with Browser Scripting. You just search for Interacting with Browser Scripting Unity on Google. You'll get to this page, and this is one that I found to be very helpful for figuring all this out. So let's look at what the C# code looks like. I have a do flap function, and this is just in my bird mono behavior. And then on the HTML page, I have a button, and I connect to that button, and I add a listener, a click listener, and I send a message, bird do flap, and that's it. Okay, so the other way is a little bit harder. This one is Unity to JavaScript. It's not that hard, though. Okay, I got my bird here, and when he dies, I'm going to do something special on the web page. Oh, man, blood red. So, here's how you do that. In your Unity assets, you create a plugins folder. I believe it actually has to be called plugins. You create this file called jsplugin.jslib. And the reason they added lib to it is that they don't want it to interfere with Unity JavaScript, which is not really JavaScript. It's a typed JavaScript weird thing. So we create that jsplugin.jslib, and we fill it with content here. I prefix this with JS_, just to make it clear that this is regular JavaScript functions. There's no need for the prefix, but you merge this in, and basically you're going to have access to this later on. Or I'm sorry, when this is called from the game, we turn the body background color to red. And what's nice about this is if you have other JavaScript code running on your page, you can call any function that's global on your page, which is kind of a little bit of a hacky thing, right? You need to have your functions be global in order for this to work, but you can namespace them all in one class or something. Okay, so, and then in the Unity C# code, we have this crazy DLL import internal. I don't know what it does, but it says so in the docs. Right, and then you can call the linked functions, right? And this is where I'm doing this. And I'm kind of a Unity noob, right? But so when I put this slide together, I just threw it in a try-catch, but I believe there's also a Unity WebGL if-def that you can use, right? And that's just so that when you're testing this thing in Unity, it doesn't crash. Okay, so let's talk a little bit about Lambda and serverless functions. This is how you get that sort of back-end behavior from the web. And what I'm going to do is I'm going out to Bing image search, and I'm asking, okay, what would you like it to rain? Dogs, right? This was hastily put together in a hotel room, so sorry about the bad collision boxes, but all right. What would you like it to rain? Okay, men, right? Wait for it. This is asynchronous loading, so it takes a little while. Boom. Look at all those men. Okay. I did this while you guys were partying last night. It was really fun. Okay, so there's actually a lot to unpack here, and I'm going to go through it pretty fast. I know that you guys are not web developers, and I just want to give you a taste of what's possible. Okay, so the backend uses 3 services to work. Up here, this is AWS Lambda. This is the serverless framework. This actually does deploys to AWS Lambda so that you can write your code locally and deploy it out, and it's actually a pretty nice framework. And then I'm actually using Microsoft Azure / Bing image search because it's way cheaper than Google image search, but one drawback is I was sitting at the conference and their people were calling me like 3 or 4 times during the day, like, hey, use our stuff, it's super cool. And so I got that phone call yesterday. We see you're on Azure, we want you to use it like crazy. So anyway, the front end is HTML and CSS, and then we use FileStack, which is another web service for the imagery size. And then the front end is a Unity WebGL export written in C#. Okay, so let's talk about the back end. This is an AWS Lambda function, and a Lambda function is a piece of code that runs on a server, and you don't have to worry about all of the different parts of running a server. So you don't have to worry about firing up new servers if there's a high load or any of that stuff. Amazon handles all that. You just write a function and you upload it. So this is what that function looks like. Let's see, I guess I have a breakdown. And the reason that you have to do this on the back end is that Microsoft gives you an API key, and you can't put that on the front end. Otherwise, people will see it and they can steal it for their website. That's why I have it blocked off. I think there's a frame where I forgot to block it off, though, so many of you guys are hackers. Anyway, so we pull in the image URLs, and that's via, okay. When I call this function, right, I give it a query parameter, and I put that in query parameter queue here. And then I call Bing image search, right, and then it responds with a response. And then down here, so they give you a whole bunch of extra information you don't need. This line right here distills this information down into just a couple, or just an array of URLs. And then I return the response, and this part is actually really important, this access control allow origin star. So on the web, the default security is that you can't reach out to another server and get data unless CORS is on. So CORS stands for cross-origin resource sharing, and it's important for all this stuff, especially in Unity. So you'll have things that'll work in the Unity engine if you go out to the web, and they might not work in a WebGL export because of this CORS thing. All right, and then we deploy to the serverless framework, and believe me, this is way easier than it was before there was something called the serverless framework. And all you do is a single line here, you deploy it, and then it gives you a URL where it deployed it, and you can see I was lazy and I left it as hello world. Sorry. And then this is the URL to call from the front end. Serverless is a really cool thing. I recommend this YouTube series. It's by this guy, Xavier, if you want to learn more about it. And it also lets you deploy to different cloud platforms, for instance, Google Cloud or IBM Cloud. Okay, so let's take a look at the front end of this. This is the code, and I break it down, right? So down the bottom here is where, I don't know where my pointer is. Down here at the bottom is where the click actually happens, and we go out to AWS. And then up here is where we actually start spawning dogs, cats, and men. Okay, so here's where we do that request. We fetch this URL. We return, this response is actually a stream right now, and we need to return it as JSON, and then after that, we start spawning the different things. Okay, so all this fancy code on the outside just says do this every 2 seconds, and on the inside, This is the URL that we get returned back, this toSpawn up here, right? But I'm actually appending this file stack API. And what does this do? This is a service on the web that actually, it does a bunch of things, but one nice thing is you can just tack a URL together and have a resize. So I resize this to 350. And the other bonus of this is that I get cores when I use file stack, right? I could write a Lambda function that actually does this resize, but that'd be a little bit much for purposes of a demo. And then I send the URL to Unity. So let's look at Unity code. So spawn is a coroutine that actually goes out and fetches the URL. So this is the part right here where your JavaScript code calls out to this and just sends this. So you could just put a debug log to test that this is working. And then I call the coroutine down here. Access in JavaScript. And then down in this coroutine, I use their www library to pull in a texture. And then I create the object and add the texture from URL. One more time. All right, this is actually the same as the last time. So, but anyway, just like a taste of the type of things that you'll be able to do in WebGL. Okay, so I got about 10 minutes left. Let's summarize what we talked about. Unity has been web-friendly since 2005, and it looked like they got on it just in time with WebGL. I believe WebGL will be huge. I believe that you'll start to see full games put out in WebGL format, and I do believe that it will eventually be the way that people play games. Who knows? I showed you about the nuts and bolts about how to build a WebGL, how to build a better WebGL template, how to deploy like a pro, of course, my website. We looked at the Unity compiler toolchain. We looked at how to communicate between Unity and JavaScript. Looked at how to access web APIs, and a little bit about serverless and Lambda. So my ask from you guys is, help me shape Simmer.io. There's my email address. I'd love to hear from you if you decide to use it or if you decide not to use it. I'd love to sort of just have a small group of advisors that actually are going to use the product to help me out. Again, it's just debuting, so I want to make it something that's for you guys. And then we'll run this demo, and I'll take some Q&A. Can you go to the microphone? I can't clap for myself. That's bullshit.
You touted no app store as a feature, but won't a lot of developers want to be able to have some sort of app store so they can sell their games?
Of course, yeah. And that's the long-term plan with Simmer. I know that itch.io actually has sort of an app store thing. But yeah, so right now this is for people that are selling assets and they want a way to demo their stuff. So a way for people to demo a level of a game. And then my long-term plan is to have monetization features in here. So I guess I am sort of building my own app store, but there will be many of them out there, I'm assuming. So you'll have a choice.
Do you know anything about Unity's plan with multiplayer with WebGL? It seems to me like it doesn't work right now.
Okay, so what I know about multiplayer is that you can use WebSockets, and on the asset store, they have an asset that uses WebSockets, right? So it might not be the easiest thing to set up, but it's definitely possible. So regular sockets are, I don't know actually if regular sockets work, but WebSockets definitely do, and there is an asset on the store for that, so you can look into that. And that actually uses this whole JS line to pass messages back and forth. Took a little look at it.
Was that correct that when you're uploading to Simmer.io, you're just doing the standard Unity WebGL default template?
Right, that's right. You don't actually.
It gets
Sorry.
reconfigured when it gets up to Simmer.io?
Right, so I use a serverless function up there to actually look at the contents of that page and munge it in such a way that it, basically everything that I showed you is what I'm doing. So if anyone wants to make a competitor, you're welcome to. All right, sweet. It was really good talking to you guys. If anyone wants to talk to me after, I'll be up there for a few minutes. Thank you so much.